Here this question is asking, determine the range of k for stability of unity feedback system whose open loop transfer function is g of s is equal to k over s times s plus 1 times s plus 2. So here they are asking for the range of stability of unity feedback system, and they have given the open loop transfer function. Now let's see how to do this. So first of all, what we have to know is we have to know the equation for the closed loop transfer function. Closed loop transfer function the equation of that one is given by c of s over r of s is equal to g of s divided by 1 plus g of s times h of s. Okay, so here the g of s values provided to us right here. G of s is equal to k over s times s plus 1 times s plus 2, and h of s, if it's not provided in the question, we assume it to be 1. So if we plug in the values, then this one will become okay. From the problem, we know that g of s is equal to k over this value. So instead of this g of s, we can replace that one with this one. So the c of s over r of s will become this value instead of g of s, that's k over s times s plus 1 over k over s times s plus 1 times s plus 2. So this is k over s times s plus 1 times s plus 2, and that one divided by 1 plus g of s h of s, and 1 plus, instead of g of s we plug this one, h of s, if it's not provided, we assume it to be 1. So this is going to be 1 plus, and the exact same value, that is k over s times s plus 1 times s plus 2. Okay. So from this one, what we can do is, instead of what we we can write this one as this one in the numerator and the denominator, like this, k over s times s plus 1 s plus 2, and in the denominator, instead of 1, I can write it as s times s plus 1 times s plus 2 divided by s times s plus 1 times s plus 2. Right, if you want to make 1 into this, we have to multiply top and bottom with the same thing. So here like that, we can bring it to this form. Why we bring it to this form? Because if we do that, then we can add this one together and make it simpler. So here this one, other one remains the same, k over s times s plus 1 times s plus 2. Now what we can do is, since both of them has the same denominator, we can add them together. So the top part remains the same, that is s times s plus 1 times s plus 2, and in the denominator we are going to have s times s plus 1 times s plus 2 plus k divided by the same denominator, that is s times s plus 1 times s plus 2. Okay, so here if you notice the top part of the denominator and the bottom part of the denominator, both of them are same. This is k over this one, mean this is equivalent to multiplying with this here. That means I can cancel this one with this one. So we can cancel it right away like this. So we get rid of this, and the simpler term of this one will become k over s times s plus 1 times s plus 2 plus k. And this is the simplified answer. And the characteristic equation is whatever the value we left in the denominator. So here in the denominator, we have s times s plus 1, s plus 2 plus k. That's our characteristic equation. So let's note that one in the next page. So we can say the characteristic equation is whatever left in the denominator, which is s times s plus 1 times s plus 2 plus k, and that is equal to 0. Okay. And we can also simplify this one by multiplying these two terms. So s times s square, so s times s square, s times 2 plus 2s, and 1 times s. Okay, 1 second. Okay, so 1 times s is 1s, and then the next one 1 time. Okay, s times s is s square, s times 2 is 2s, 1 times s is 1s, 1 times 2 is 2, and then outside we have plus k right here. And after we expanded this, we can multiply with this s. In that way, this one becomes x cubed plus 2s. We can combine these 2s and 1s, so that's going to be 3s square, and then plus 2s plus k, that's equal to 0. Okay, so the next thing is we had to look at the coefficient of each of these powers. So here we had to look at s cube, s square, s power 1, and s power 0. And for s cube, what we have is 1, the coefficient, and the unused term is 2. The one next to it is 2. And s square is 3, and the unused term is k. Okay, we take like this, like we only take care of cube and a square, and we have to see what is the, like, if I'm looking at the odd number, I look at the next odd number, the coefficient is 2, and then I look at the square and the next even number, you can say s power 0, so that one is k. And this one is helpful because now we have to find out s power 1 and s power 0. That is not gonna be just 2 and k. We have to find the expression for this. That's for that one we have to use this equation like this. So here what we do is, to find out the expression, we multiply this one with this minus this one with this divided by whatever the value here. Okay, so here this is 3 times 2 right now, and then minus 1 times k, and then that one divided by whatever here, that is 3. And if you simplify this one, this is 6 minus k divided by 3, and that's the value we have to put it right here. And here we have nothing, so we assume this one to be 0. And for s power 0, we do the same thing. We multiply this one with this one with this, and divide whatever here is denominator. So if we multiply this one with this, that is 6 minus k divided by 3 times k, and then minus 3 times 0, that is 0, divided by this one in the denominator, that is 6 minus k divided by 3. So from this one we can see this one cancels, this is nothing, we can eliminate it, so this will be left, and this one cancels, and then k left, so the k is the one that we have to put right here. Okay, so here what has to happen is this one has to be positive in order to be stable. So for the S1, if you see, if I put 6, this will become a 0, and divided by 3, that's become a 0. So it should be less than 6, because if I go greater than 6, that would become a negative number. 6 minus 7, that's a negative number. 6 minus 5 will work because 6 minus 5 is a positive number. That is 6 minus 5 is 1 over 3, that's a positive number. So whatever the value here should be, this k should be less than 6 in this case, and for this one the k should be greater than 0 in order to be positive. So we can mention it in the next page. 1 second. In the first case, from s power 0, here if you notice, s power 0 k, it just shouldn't be 0 or below. Other than that, it will have the positive number. So here we can say if k is greater than 0, then system is stable. And for the next one, we have to see this s power 1. For this one, the 6 minus k divided by 3 should be a positive number. So we can say from s power 1, if 6 minus k divided by 3 is a positive number, then the system is stable. Okay. So in order for that one to happen, this k should be less than 6. So we can say here 6 minus k divided by 3 should, if it won't be a positive number, then k value should be less than 6. Okay, so we know that from this one we can say the range of k for stable is 0. It should be greater than 0 and less than 6. In that way, it will satisfy both of the condition. For the first one, it should be greater than 0. For the second one, it should be greater than 0 at the same time. Yeah, it should be greater than 0 at the same time. It shouldn't be greater than 6, because if it's greater than 6, that's a negative number. Okay, I cannot take, if I take less than 0, that will satisfy this, but the thing is that will contradict with this. That's why I cannot take less than 0, because it should satisfy both of the condition. If it's less than 0, that will contradict with this one, because this one becomes negative, so we cannot have that. And if it's greater than 6, greater than or equal to 6, that will contradict with this one. It cannot be 0 or negative. So in order for the both of them to be positive, it should be greater than 0. At the same time, it should be less than 6. That's why this is the range of k to be stable, and that's the question is asking for. Determine the range of k for stability, and this is how we find it. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.